So now they're using the notation that I showed you up above, which is I want to take the derivative. And so on the left, of course, I'd have f prime. And over here, I have my new fundamental theorem of calculus, the second one. And I say, hey, it fits the model. I have a constant on bottom. I have an expression on top. So I'm going to plug that expression in and then take the derivative of my expression. So I'll have 1 over x squared times the derivative of my expression. So I have 2x over x to the fourth, which is 2 over x cubed. Oh my gosh, I think these are getting easier. Same thing on the second one. So I want to take the derivative. I'm taking the derivative of the antiderivative. So they kind of sort of cancel each other out. I just have to remember that I'm substituting in and using chain rule if it's an expression. So it fits my model. I have a constant on bottom, variable on top, which is getting plugged in, and then the derivative of the variable. So I'll have the square root of 1 plus the quantity 3x cubed times the derivative of the variable, which is 3. And so if I simplify that, I'll have 27x cubed inside the radical. And oh my gosh, this is like crazy easy, Torres. Bring me another one. So I'd like to talk you through this next one. Keep in mind that on the last problem where we had an expression on bottom, a non-constant, and one on top, what I said we could do is split them. So I could go from j of x to 0 for my antiderivative. Oops, I don't know why I put an x in there. And then I could add from, 0 to k of x. And of course that beginning piece, I need the variable piece to be on top. So I would have to rewrite that by negating. I'm allowed to flip them. And then I know that I'm supposed to plug the expression in and take the derivative. So on this very first one, I would be plugging this in. So I would have, keeping the negative out front, of course, f of j of x times the derivative of my expression, which would be j prime, plus, and then same issue over here, I would plug that in. So f of k of x times the derivative, which would be k prime. And oh my gosh, I think this is a match for what we have up on top. It's just that this is second because it's subtraction. So it's second. And this is first. Okay, so let's try that on the next one. And just as a quick note, notice it's really as though I'm putting in the top and subtracting the bottom, which is similar to what we've been doing integrating. So when I try it on this next one, of course I'm going to plug in the top first. So it'll look like 4 times x plus 2, and then plus the 1, and then times the derivative of this, but the derivative is just going to be 1, minus, and then I'm going to plug in the bottom expression. So it will be 4x plus 1 times the derivative of that expression, but the derivative of x is just 1. And so when I'm all done distributing and combining like terms, I just get 8. See you in the next video, kids!